They wanted $840 for 12 simple pieces of cast aluminum. $840. So I said no. In this video, we're bypassing the solar industry supply chain by melting down scrap metal in my backyard foundry to cast my own heavy-duty solar racking caps. We're going to talk about the 3D design, the thermodynamics of pouring liquid metal, the catastrophic failures that almost ruined the project, and exactly how much money you can save when you refuse to buy retail. Initially, I had to figure out exactly what I was building. I sat down, calculated the dimensions of my solar array, and figured out how many panels I'd need to hit my power goals. I plugged all those numbers into the Iron Ridge design software. The program spit out a massive, highly detailed parts list. But when I scrolled down to the bottom, pure sticker shock. Solar racking is expensive. The base estimate for the aluminum rails and hardware came out to around $4 grand. And keep in mind, that didn't even include the heavy steel pipes, which luckily I already had on hand. $4 grand for what is essentially metal shelving for solar panels. That just didn't sit right with me. So I did what any other DIYer does. I started hunting for deals. I did find a local supplier with a stack of heavy-duty XR1000 rails on clearance for $60 each. But then I hit the next major hurdle, the post caps. My design called for a 12-post ground mount. Each one of those steel pipes needs a heavy-duty aluminum cap to secure the top rails to the structure. Online, the factory caps were going for about $70 a pop. That's another $840 just for 12 cast pieces of aluminum. I looked at the pictures online, looked at my empty wallet, thought, I have a foundry, I have scrap aluminum, I could just make these. After buying the necessary steel U-bolts for $50, DIYing the caps would save me nearly $790. While I was at it, I figured I'd make the rail connectors too, saving another $250. The only thing I absolutely have to buy retail were the universal fastening objects, the UFO clamps to lock the panels down. Now I know exactly what some of you are thinking. Dude, you're crazy, just buy the parts. And look, if we're talking strictly about economics and time, you might be right. I absolutely could have just worked a few hours of overtime at my day job and bought the factory parts. Between designing the 3D model on the computer, 3D printing the patterns, revising the dimensions, engineering the risers and feeders, and actually pouring all the caps, I spent a massive amount of hours in the shop. If I paid myself minimum wage, I might just have broken even. But here's what the just buy it crowd misses. If I had just bought them, I wouldn't have gained anything but a lighter wallet. There's an overwhelming, almost addictive sense of satisfaction in knowing you built something from scratch. When I look at this solar array, I won't just see savings on my utility bill, I see my own engineering. Next time I need to cast a large structural aluminum object, I will have the benefit of this exact experience. I'll know how the metal flows, how it cools, and hey, I might just get it right on the first try. It certainly didn't happen on the first try this time. Aluminum casting looks simple on Instagram. You melt some cans, you pour it in sand, and boom, perfect part. In reality, it's a delicate dance of thermodynamics and fluid dynamics. My first two attempts at casting these heavy post caps were complete and total failures. When you pour liquid aluminum into a mold, it shrinks significantly as it transitions from a liquid to a solid. To compensate for this, you have to design a riser, a reservoir of molten metal that sits above the casting and feeds liquid aluminum down into the mold as it shrinks. I thought I had designed my riser plenty big enough. I was wrong. As the caps cooled, the riser solidified, pulling metal from the core of the cap itself, leaving ugly shrinkage cavities, right where the structural strength was needed most. They were useless duds. But I didn't get discouraged. I treated it like a science experiment. I dissected the failed castings, cut them apart, and pondered on it. I went back to the drawing board. I increased the volume of the riser by 50% and adjusted my pouring temperature. The result? The next 12 casts came out absolutely beautiful. Crisp edges, dense metal, and perfectly structurally sound. Too many people today are terrified of failing. They try a new skill, it doesn't work the first time, and they throw their hands up and quit. But failure isn't the opposite of a success. It's a necessary ingredient for it. You have to embrace it, dissect it, and treat it as free data. Thomas Edison famously failed thousands of times before perfecting the incandescent light bulb. When a reporter asked him how it felt to fail so much, he said he hadn't failed. He just found thousands of ways that didn't work. That kind of gritty perseverance feels like it's severely lacking in our current instant gratification society. When things don't go perfectly on day one, people give up. But if you stick with it, push through the duds, fire up the furnace anyway, the payoff at the end isn't just a cheaper solar build, it's the knowledge that you can build dang near anything. Now that we have these caps cleaned up, we can move on to the next stage of the build. Come on back and see which hurdle will trip us up next time. Thanks for watching.